We good?
Yeah, after you finish, just pass the mic to the moderator.
Oh, okay. All right, everybody. Moving on to the next panel. This will be my easiest introduction of the day because I'm going to hand over the mic to Stefan and he'll do the rest. There you go.
Thank you very much, man. I think we all feel great to be here, and thank you all for listening, and we'll go straight to the point. Today with us are Miao from Superfluid, Mario from Ethereum Foundation, George from Consensus, Anton from Chain Security, and Nebojsa and myself are from Tenderly. Guys, if you want to say like 1 or 2 short sentences about yourselves, introduce yourselves, and we'll get straight to the point.
Oh, okay. Yeah, I was building Super Token, yes. Yeah, so I'm from Superfluid. We've been building the magical token called Super Token for quite a while, and I don't know enough about EOF, but I hope I can provide some also my new thoughts about it also for this talk. Thank you.
Hey everyone, I'm Mario. I work with EF, specifically protocol support team, which is a team which helps to coordinate the work around core devs and also to test ship hard forks. So I'm more of a technical part of this team where I dive into some research around the current research, and I've been running the protocol fellowship, so I'm helping to onboard new core developers. Yeah.
Hi everyone, my name is George. I'm from Consensus Diligence, and I mostly do smart contract security audits, some tooling, and some ZKP research here and there nowadays.
Nice. Hey everyone, I'm Nebojsa, one of the co-founders in Tenderly. We are building a developer platform that helps builders be more productive and efficient when they're building and testing smart contracts. Mainly, I'm working on our custom virtual machine that is capable of extracting more data during the runtime.
Hello, my name is Anton. I'm from Chain Security. We are also doing audits for Ethereum smart contracts. And also internally, we're doing different tools and keeping a close eye on all the changes in the bytecode and EOF including. That affects our security tooling a lot, I would say. And yeah.
Thanks, guys. So, for the intro, Nebojsa will really shortly go through like what Ethereum Object Format is, but we wouldn't want to focus too much on the technical aspects of it today. We would like to focus on what kind of impact EOF will have in the space and on developers. So, Nebojsa, take it away.
Right, I'm going to do just the short intro, and anybody from the panel can also chime in if they have something to add. So basically, Ethereum Object Format introduces this new way of how smart contracts bytecode should look like. By that, I mean it restricts how exactly the sections of the bytecode need to behave and look like. And this has a lot of implications. The first one is that on the runtime, we no longer need to do and perform some checks which can, in essence, help us with the scalability of the whole Ethereum. But as a consequence, we need to do some checks on the deployment time. Right. Yeah, that's basically it. Yeah. I mean, if anybody has something
I would mention just one important thing, that like the whole name is wrong here. Like I was telling the organizers, and I think it was changed in the schedule, but it's still here. It's not Ethereum Object Format, it's EVM Object Format. Okay, so we are talking about the Ethereum Virtual Machine, the heart of Ethereum, I want to say the brain, the execution environment, which right now it has to work with just like a blob, basically, just like bunch of bytecode. When you are deploying a contract, it doesn't have any structure. It's just bunch of code, and the EVM goes code by code, bytecode by bytecode. First, it verifies whether it's correct, whether it can even execute it, whether it exists, whether it has enough of gas, whether it doesn't break any computation, and this can be externalized to do it at the moment of deployment, which is great not just because we save the time at execution, but also we will prevent having just a mess on the chain, which is unexecutable. Just to mention, right, like, so now instead of just like random pieces of code, it will be structured like we have a header, this is the code, this is the data, and when the EVM comes, it can tell like, okay, the header explains the version, that's one important thing, that will be the versioning, and this is the code that I'm looking for, and I need to verify this, right?
Right. It's good that you mentioned versioning, because that's basically where we wanted to start. So, like, what will be the implications of versioning? I mean, how do you see that going down and propagating through the levels all the way to the depths or whatever you're building?
Should I talk like it?
I can choose who talks, but George looks like he wants to say something.
Go ahead.
So
Yeah, no, I think since we're talking a little bit less technically, more like narrative almost at this point. First of all, I think one thing I want to say is that this is the first big change to the EVM itself, especially after all of these upgrades to the protocol. Now it's finally we're putting the spotlight on like one of the main things probably about this whole Ethereum ecosystem. So that's first big change. And then the second, that within the change itself, we have the notion of versioning. So it's kind of an interesting thing how now we're going to be looking at even more explicitly looking into upgrading very core parts that are not even necessarily backwards compatible parts of the protocol as we're going to be upgrading them. And then on top of that, we're going to even have an explicit versioning part to it, meaning that we are explicitly looking to have several different potentially not compatible versions of code kind of living on Ethereum, and we might have, correct me if I'm wrong, some contracts that are going to be able to speak to each other, in future potentially not being able to speak with each other. Let's say if we have EOF version 13, right, it might not be able to be speaking to version 6. And then we were speaking in the green room right before this, how it might be interesting that this might spill out to different layer 2s and how they might have their own dialects of the EOFs running there in different containers or code containers that might be a little bit slightly different from the mainnet and might be compatible, but maybe one way, not the other way. And just overall, kind of, I think it's interesting how this isn't just a major upgrade of the EVM itself, but in itself, within the upgrade, we have a notion of that is going to be changing more and more.
I also wanted to maybe like add something that Mario mentioned before, like that's basically this could be chunk of an executable code, right? It's actually one of the cool things is that there are going to be introduced also data sections, right? Yep. For like bytecode is not only executable code. For many things, the parts of a bytecode contain actual data because there is like code copy of codes and so on that can be used for immutables, right? The factory contracts needs to store the bytecode of the contracts they need to be deploying also somehow, right? And like alternative is doing it as storage, but it's super expensive and there is no like a way to load large chunks of storage in one go. You only can access it word by word. So it's like for many places, the bytecode is used as a kind of data storage, right? Yep. And for me, it's like, this is honestly a really nice feature because now you can clearly distinguish between what's executable and what is used as like data, right?
But thank you for mentioning like that's one of the important things to mention that like it's the biggest upgrade to EVM in a while. Like, I mean, like the most significant upgrade we had was push 0 this week. But, yeah, like the EVM today looks almost the same like 3 years ago. And the folks from the Epsilon team, Axik, Pavel, Andrei, have been working on EVM upgrades since like the EVASM era, and this is something which they put a lot of work into. So I'm hoping that it's going to like these changes in the EVM are very slow. It's also one thing. So we mentioned the versioning. Yeah, I wanted to react to that because I mean, it's like we'll basically now have different, I want to say versions of EVM, but it's not like fully what people might imagine because there is you cannot the changes that can be done in each version are still limited. It's more like it's the new version can add new features. It cannot change things, right? So we can see that the contract or the developer can actually see that he's using this version and he's compatible with the new features, let's say. So it might be even easier to add more features, but also it's like maybe more standardized approach to have the various EVMs around the ecosystem, especially for example layer 2s, right? Because I think Arbitrum already announced it, but the idea was already like a year back at least. Like we could have kind of beta version. I don't quote me on this, but like another like version of EVM where we improved something, and this is running on layer 2s. They tested, and maybe it get boosted up to mainnet at one point, but. Again, like this breaks the equivalency, right, which some people are trying to reach, and generally, like there is a lot of issues with EOF as well. Like it's not all fairy tales. Like it's pretty a big problem to solve. That's why it got pushed from Shanghai to maybe Cancun, maybe Prague, yeah, and one thing is that now we are going to basically break the EVM for all of the forks, which is like half of the crypto coins out there. Yeah.
So I'd like to add that, right? So it's not just a rainbow and sunshine, and there might be also the fragmentation. And now it's not only technically a new arena for us to innovate, but also probably politically a new arena for fragmentation, right? So there are political actors like Q switch for smart contract. What if someone decide, oh, on this EVM, there's specific feature enabled by better versioning, which is technical excellence perspective. What if the political kind of hijacking, right? So I think that part we often less talk about in the technical circle, but often in crypto there's a lot of this kind of good and evil sometimes can emerge as a conversation.
Especially now as we have a lot of layer 2s that are coming out like white labeled, like exchange-based layer 2s, like let's say the Coinbase one. Like, could definitely see something like that there.
Yeah.
And as well as you mentioned, like the fragmentation of the chains, but you also have the fragmentation in the tooling space. So the layer above, like the L2s is like, and the EVM is programming language, and the layer above that is the tooling, the security components, the decompilers, etc. And they would also need to keep up with all the improvements on the object format as well. So, yeah.
I also wanted to add something about the features, because it was mentioned here, like basically we are adding features, but honestly, with the EOF 1, at least like how it's now, it's technically we are constraining how the code can look and what it can do. It's technically a removal of features, you can say. It's by forcing this blob of data that's now to be of a certain shape, we are technically disallowing certain behaviors that were kind of allowed before. And I think, I don't know if it will make into the final EOF 1 or it will be some further EOFs. For example, self-destruct opcode is going to be kind of replaced by something self-doll opcodes. And this is, you can say, also like a feature removal, right? And it's technically like even like there was one proposal that our engineer Hubert Riesdorf, maybe people know, proposed to EOF itself on the discussions, and it's maybe going to be accepted, is that there is no going to be longer a way to delegate call from the EOF into the vanilla EVM version, just because otherwise this will be like a backdoor to access all those features. This technically, right now, are removed in EOF, right? But of course, like going further, maybe EOF 3, 4, 5 is going to be more feature-rich than EOF 1, right?
Yeah. So this is what you actually just said is a nice segue into like the following topic, which is basically, I mean, sure, there are like good sides and bad sides, and people are going to use EOF in various ways. But like, how do you see it starting to propagate in the developer community? Like, what do you see are the first use cases or usages for EOF? In which types of projects? I mean, any kind of thoughts on that front you want to share?
I guess one thing is we're also trying to battle this question earlier and trying to think like how is the adoption actually going to happen. One thing that kind of springs to mind, and that often how these, especially in our space, these things happen is there's probably going to be a big player, like a big project, big protocol, you know, the Uniswaps of the world that's going to release their new smart contract version, and they're going to have it probably, you know, all up to date, and then all the T's crossed and the I's dotted. with the EOF container version, with the newest EOF, whatever that's going to be, EOF 1, or whatever that form is going to take. And they're going to say we're now, fully doing it up to the EOF contract with all the things removed that need to be removed, all the things there that need to be there, and then other players later on, as is usually the case in our space, will start to fork this, and that's going to start to propagate this, and then since these are going to be popular contracts, our security tooling is going to need to start to catch up with this, and it's going to start to adopt these features more, and then other security tools are going to start to follow, and slowly everything is going to kind of avalanche from there. It's definitely just one of the ways I think that adoption is going to happen, but probably in my head, a big player is going to do this, and then that's where it's going to go.
It's funny that you mentioned the Uniswap, because I mean they've been pushing for the 1153, is it? The transient storage, right? I mean, they had their own solution basically, and now they kind of have to wait for the EOF. Yeah, I mean, because I mean, first of all, it needs to be implemented in compilers, right? I mean, Solidity that doesn't have it because it's not even specified yet. We don't have final EOF specs. So like what I'm hoping for is that it will be on the Solidity level or the compiler level. It will be natively or like won't be like some optional experimental feature, but it will be easy to use. So it will be basically utilized automatically by any contract, and yeah, hopefully we'll save a bunch of gas. Yeah.
I'm not so sure if the incremental change is the best way to actually get this out. I'm just wondering if there's chance for a bit more leap forward type of improvement that maybe something from scratch, like a new chain or something that they say, hey, how about we start from scratch in this particular chain to demonstrate something like a really, really new, as opposed to incrementally fix something in the ecosystem already. So, but you guys probably should know more.
It's actually interesting that you talk about like starting new chains with these updates, because with things like ZK EVMs, they need to completely rewrite all their circuits with every single upgrade. I even wonder that, say, because there's a couple of ZK EVMs, supposedly already alive today, for them to upgrade with this new EOF version, I wonder if it's easier to just start a new layer 2, and then start a new instance of their ZK EVMs with these upgrades, as opposed to maintain the existing one and then try to upgrade it to the newer version with the EOF. But to actually support these leaps, as what you're saying, because for them, especially for these circuit-based ones, it's going to be very difficult to always keep up to date with incremental upgrades for all of this.
Yeah, I mean, it's great you mentioned it. Like, it was one of the points to be raised. Like, there's like 5 ZK EVM projects right now, and they will have a it's not trivial to change something so big as EVM there or the EOF there. But also for all of the client teams, for all of the Ethereum clients, what it means now is that they basically need to maintain different versions of EVM, because you want to do this full sync, and now you need with each hard fork, or like in this case, let's say with each EVM version, an EOF version later, you need to execute this piece of introduction. Then okay, we switch to the new one, and that's a lot of code paths to be maintaining. Yeah.
And on the adoption, I think George and Mario, you mentioned a good thing. I think that this space is incentive-driven, and like dApps need to find a way to to reach the broader audience, and for that they need better virtual machine. And so they're pushing for the innovation on the virtual machine. Then the virtual machine is pushing the innovation on the compiler level. Then they are pushing the innovation on the tooling, and then we are also giving it back to the dApp developers. Yeah. So it's like this whole circle of like incentives that, and everybody is pushing in the right direction. Yeah.
But yeah, of course, it's like this innovation. I think that essentially, at least for Uniswap as well, it was motivated by doing the same things but cheaper, right? Yeah. It's like in the end, it's transaction gas you need to pay for, and the less you pay, the better. And exactly like the EOF, how I see like we are disabling jump opcodes, right? And introducing new static jumps and like call Fs, and because exactly they're not gonna need to do the checks on like validity of the destination addresses and so on. I think it's most likely they're going to be cheaper, and this adoption can come just from the fact that using EOF1 is cheaper, right?
I also recall, I think that now, once EOF comes out, on-chain validators, specifically for like layer 2s, like I think for Optimism, say, the Arbitrums of the world, I think even for them it's not going to be actually cheaper to run their on-chain verifiers to actually verify the state changes submitted by sequencers. And that's cheaper proofs, cheaper rollups, and that's downstream cheaper for the users of those rollups. That's also more adoption, right? If I'm one layer 2 that doesn't adopt this, and my competitor adopts it, and now suddenly they have much cheaper gas costs for their transactions because of the EOF, because their on-chain validators are that much cheaper, I'll be that much more encouraged to adopt this new version as well.
Do you guys think, I mean, one of the biggest things with EOF is definitely a much better utilization of resources and paying less gas and cheaper gas. But do you think that EOF will have an impact on security, a positive impact on security, as we hope it will? Or, we're going to find some other problems down the road?
I would say it's really a good question, and it's really undetermined.
That's why I'm here.
Yes. Last thing I remember was one update in Constantinople, I think, where the storage operations were repriced, and something like Ethereum, Solidity was using the gas limit for enforcing operations during the calls that just need to send the value, and you had enough gas, on like the 2,100 gas, I think, to basically emit an event. And after the reprice, you actually could do some storage operations, and it was problematic. In this case, what I'm thinking, what's essentially happened in that update and why it's relevant to us, it's the system allowed more behavior than it was before, right? And now, with the EOF, at least how it looks like, again, the behavior is not added, it's removed mostly, right? So at this point, I would say once there is no backdoor to delegate call back to the more feature-rich EOF, I'm not super concerned about the security, because you're technically just making more restricted systems that shouldn't break easily. But of course, because the tooling needs to catch up with all these changes, maybe there's going to be some compiler bugs again and so on, right? This is always a danger, right? It takes a while to test and to validate such big changes. So yeah.
You mentioned before the CallF opcode. I think it's going to especially help us validate not just certain contract, but look at the whole chain more holistically and understand better what's going on. Like right now, when you have the EVM execution, you basically almost have no idea what's going on with non-verified contracts. But with the EOF and the code sections, we can better understand what's happening inside there.
Yeah, I think to that point, especially because a big thing right now in security is doing war room analysis, a post-mortem analysis, and trying to determine what happened where with what contract and what happened with those transactions. With the EOF, supposedly it should be much easier to actually perform some of these analytics on the attacker contracts and whatnot. But it's interesting because assuming that once the EOF comes out, you will still be able to for some time deploy legacy contracts, which are a lot more of a random byte, not random, but unstructured bytecode that is much harder to actually decode and understand. I wonder if the attackers in those cases will exclusively deploy non-EOF contracts to throw off all the new tooling that will be better able to understand EOF contracts instead. But of course, that's I think going to be attackers are going to attack always. Haters going to hate. But on the other hand, for good contracts and for good bugs, non-maliciously occurred bugs, with EOF, it's going to be much easier to understand what happened and what's going on there and what those attacks did.
Besides EOF obviously improving the development process and hopefully the average quality of a smart contract, do you guys see EOF for smart contracts being used in any kind of well, I don't want to say innovative ways because everything that we're doing in this space is more or less innovative, but something that we haven't seen up until now. Is it going to open some new doors for people to do things differently or to do new things or something like that?
Immediately, no.
Oh, of course.
I mean, in EOF itself, like the ones that's going to be recent, it's like, again, less features. So I would say something that's now present in Solidity, like function pointers. It's going to be pretty harder to do it without dynamic jumps, right? But what's big thing is versioning, right?
Yeah.
And with versioning, all the doors can be opened. So.
Axig had this talk, but it was like a year or maybe 2 years ago, about how EOF can work with account abstraction.
Yeah.
So actually we might see some improvements on that front, like actually utilizing it for more effective or more feature-full account abstraction. And yeah, I'm wondering how the data, like now when we have the space for the data, whether it will be maybe, I mean, what I was hoping for before was that this can be utilized better to store the L2 data, but we will have blobs for that, maybe sooner than EOF. So yeah, we'll see about that.
Sure. And like, since the effects of EOF will propagate, and you guys mentioned like we need to develop tooling and everything else, and this is not a tenderly shill, although it's our panel. How do you think EOF will impact tooling as a whole?
Well, I can start. Yeah, we're doing like security tooling, right? And sometimes like we did like static analyzing on a bytecode. Technically, it should become easier for such kind of tools that needs to dive into bytecode analysis, just because dynamic jumps were, let's say, not the most ideal thing to deal with, especially during like some symbolic execution. When you can jump to symbolic, I mean, Solidity things got, in most cases, had a good enough invariance where it never happened. But for generic bytecode, like it's like any bytecode that you can ever deploy, it was like a real problem. So for security tooling on a bytecode, it's going to be most likely easier.
No, an interesting thing there is, I think there were some comments also online around EOF about this, is that because we had to deal with these problems as is in security tooling, some of them, or maybe even the majority, have already been kind of solved. Like we've adapted our security tools for that. So ironically, while the impact is that it's going to be easier to create newer versions on this EOF stuff, we've already have existing code to deal with the previous problems. So we're going to have kind of like both. It's just going to be easier to adopt, I guess, newer tools and create newer versions of these tools. But also interestingly, we're going to need to maintain both for the time being to take care of the legacy contracts as well. So there is a little bit of that slightly negative thing now that we're going to have to take care of like both types of contracts or styles of contracts on chain.
I think the existing toolings definitely will push back on this, right? So because no one pays them to actually do the upgrade. It's like, like Ether's gonna have to upgrade their stuff. I mean, they're well paid, but there are people that doing other toolings may not have the position to actually support both versions, and the economic incentive has to be also there for them. Yeah.
Right. And then, you mentioned an interesting thing that the tooling is going to have to keep up. I mean, I completely agree with that. The interesting part there is that we're still in, like, this is the version 1, and the community is still yet to see the real implementation of this and the possibility of the EOF. I think that once they get a sense of how they can utilize this, what would be the improvements for them that they, if were implemented, that they would benefit from. Like, we're going to see a huge number of use cases for it, and then the tools and security components will try to adapt based on that. And I think there's like huge room for improvement in that area.
Awesome. So the spotlight is back on me. You want more hard questions?
Please.
No, I have one more because like the people, at least some of the people will want to know. Well, EOF is just getting started, and we don't really have still any kind of best practices or guidelines or use cases which you could refer to, either good or bad. Like, do you think the best practices will be led by, the Ethereum Foundation or the team behind the EOF, or it is more likely to come from one of the projects which will implement it well and use it well and act as a use case to be replicated throughout the industry?
I think it's a silly answer, but all of them. Specifically because the team behind that's pushing the EOF, the team Epsilon that you're mentioning, I mean, they're just excellent. I mean, they maintain so many pages about this, and they constantly update all of them, and they provide all of this stuff.
So many HackMD docs, yeah.
Yeah, exactly. I don't know how many HackMD docs I had to go through for this panel. So without a doubt, I feel like once we get closer to implementation and once we have all of these things already set up with the specs and whatnot, they're going to also give out, here's what we think is best practices, because of course, I mean, it's their child, their baby. But likewise, I think, as I was mentioning earlier, I think one or two bigger projects are going to try to jump on this to also claim the spotlight, quite frankly, say, we're the first big one that adopted fully this EOF spec, and here's how we did it, here are our best practices, and then that's going to be the new holy grail of other developers' projects to follow this. So, but I do think there's definitely going to be different pushes, and some for altruistic reasons, like the Epsilon team, to help out with their own little project for the sake of the Ethereum ecosystem, and some a little bit more lucrative to say we are the first ones who got this EOF spec right, and here's our best practices, and do it like that.
Yeah, just to mention again, with the HackMD pages, I believe that AXIC made some Solidity examples or some examples of how EOF should be used. Not sure if it's best practices, but because we are still too early. Not that we don't have implementation, the specification is also not properly figured out. What I would recommend, the latest reading is the Mega EOF endgame, if I'm correct, right? So that would be the current state of the EOF. And then, what I'm interested in, or what will be fun, will be the race to be the first contract, not do it properly, but just to be the first EOF contract on the mainnet. Yeah, we saw that with Push Zero as well.
First ZK EVM.
Yeah. So you can make NFT out of that or whatever. Yeah. First EOF on mainnet.
Well, we probably will make an NFT out of it. We have a couple of more minutes. I would like to leave this time for you guys to share some final thoughts or whatever you find interesting about EOF, or whatever crosses your mind.
I actually have a question to the rest.
It's not a question, it's a statement.
Oh, I have a question. So we mentioned that it's best practices, but this best practices, you mean for most developers, they are not working with the bytecode, right? They're working with Solidity. In this case, are you thinking that Solidity will change a lot because of how the bytecode that Solidity needs to compile into will change? Because honestly, it's there's a layer between developers and the bytecode, which is Solidity, and I expect if it's done well, people won't even feel the change. Maybe it's the only best practice so far, don't use function pointers.
Well, I'm not really quite sure on this one, but I feel and again, correct me if I'm wrong, colleagues, but you could end up utilizing the data part of the code a little bit differently, right? And I feel there could be some clever tricks and best practices around that could be utilized. So things like that, I think, could come up.
So, the best practices are inline bytecode, right? If you are a proper Solidity hacker. So, there is the layer. But, that's what I was mentioning. I hope that Solidity implementation, the compiler will work so smooth that, we won't even notice. But still, for example, version is something that you need to work with, right? There will be some subtle changes that we notice. Yeah.
It's very interesting and speculation. What if Viper does EOF better than Solidity?
Actually, I wanted to mention that's another thing with the tooling that I hope that Viper will catch up on EOF, and FE as well, which is also already production ready, and now they will have a lot of work to catch up as well. Yeah,
but in a way they have less work to do because they haven't been so spread out. But I get your point completely. Nebojsa, some closing thoughts?
Just that I'm really excited about the implementation of the EOF. It's been like, what, 9 years since we made any like significant changes on the EVM bytecode, and this opens the door to like new possibilities, and like once we change the base layer, the layer above that are going to change as well, and probably introduce some new way of developing, and introduce ways of having more security on each above layer as well.
Yeah, I completely agree. I think the most exciting part for me is like what this change means, and that it's not a protocol change now, it's the EVM, the computing change, and in itself it has suggestions for future changes and future upgrades. And I feel like it's just going to encourage a lot more, maybe even wild experimentation on what could happen with the EVM later. And yeah, that's just exciting.
Awesome. I honestly completely agree with that. Guys, thank you so much for being a part of this panel. I think I speak in everyone's name that we all enjoy this. And for you guys, thanks for listening. And I hope you found this fun and useful. A big applause for the guys.
Thank you so much.